is my rover design. It's quite small and compact in comparison to the maximum we were given, which was 300 millimeters by 300 millimeters. It includes 3 main features, including a robotic arm, a mobility system, and a power source. It closely mimics that of the Mars 2020 Perseverance rover. To account for tolerances during the manufacturing process, I kept it to 1/100th of a millimeter. This is pretty standard for most projects made using millimeters, and just to keep it to standards and speculations and specifications, I also defaulted to this tolerance as well. It's important to keep tolerances to a minimum when working with such intricate projects such as this, to account that all the products and components still function properly together despite human error and some mishaps that might occur during the design and manufacturing process. And although the design itself is based off of the Mars rover, the robotic armature is its main feature, comprised the design itself is comprised entirely from my own. It is based heavily off of products and research that I found online from other creators that I saw, and I opted for a really mobile and flexible armature. That way, despite the rough terrain and harsh conditions that the rover may experience, the rover is able to adapt to the different conditions and is still able to perform its function. It's also important to note that this is no way near a full functional design for a rover. It is merely going over the basics of it, basic components, basic shapes. It does not include the intricacies behind wiring or material, structural integrity. It is not built 100% to function. It is purely based off of design and the accumulative knowledge that we collected over the semester to kind of showcase our learnings with using the software program, specifically Autodesk Fusion 360, and to demonstrate our understanding of using the product and using the software as a whole. Focusing in on the mobility system, the mobility system is comprised of 3 main parts. We have, scratch that, 4 main parts. We have the wheel itself, the wheel bracket, which connects it to the wheel armature, and then this is all held together using pins and bolts. Now, the project itself did not specify to go into such detail, but alas, I thought it was important to demonstrate how exactly the components themselves function together. The armature itself is meant to mimic that of a suspension armature to account for the rough terrain that the rover will have to experience on Mars, especially accounting for the rocky terrain, the rough terrain, and the harsh conditions present. The suspension arm itself allows for the wheels to account for any resistances that it experiences on the field. The wheel itself has rigid components as well as revolutionary components. The wheel is connected to a wheel axle, and this axle is connected to the wheel bracket. The connection between the wheel bracket and the axle are fluid so that when the wheel itself turns, the entire armature does not turn with it. The pins and the armature joints are there to account for the flexibility of the structure and the mobility scaffolding so that the rover does not experience major damages while traversing or going through the field. All in all, it's comprised of multiple components and they're all locked together. The system adopts a generalized six-wheel design, again, closely mimics that of the Mars 2020 Perseverance rover. It is an all-terrain vehicle meant for the Mars environment. Um, the wheels themselves, again, they're supported by the wheel armature, and the armature itself is rigidly connected to the body shell. Claw is the most intricate part of this design. It took quite a while to kind of get the workings of it right, but once figuring out revolutionary, how the joint revolution function works, it was quite easy to go about it. The claw itself, again, is the most intricate part and is the most proud part of the design that I would like to mention. Kind of just showing the claw itself. We have the individual arms kind of functioning all together in order to clasp around objects, and the arm itself allows for revolutionary moment, vertical, translational, multiple direction. The base on once attached to the rover can rotate 360 degrees, and the armatures themselves can turn as well. Again, this allows for max mobility of the arm in order to reach places that the rover itself may not able to go. And again, this is just to collect specimens and to further research on Mars.